So what I want to show you guys is, so this is the curriculum path we are following, right? So we are done with part one, which is a machine learning prereqs, right? So we used to like Python, data analysis, NumPy, and pandas, a little bit of stats, right? All that is done. So now we are going to do what we call basically what I call essential machine learning. And if you look at your guide, our weekly guide here, right? So kind of see the spread of how we are done, right? So the last week we did stats and data cleansing, and sorry, the week before last, and the last week was a break week. So this week we are going to go into feature engineering, which if you look at the sort of overall curriculum, sort of we are kind of getting into machine learning now, right? So this is pretty exciting. So we're kind of done the basics, and I hope you guys are comfortable. Again, if you're a little behind, if you haven't done one or the other, don't worry, right? You can always go back and kind of read and do some assignments. But we are going to be sort of keep moving forward, right? Because we don't want to lose too much time in the basics. That's it. Any questions so far, guys? Any comments, questions? Let's see. So one question is, what if I'm joining this week? So again, if you look at the curriculum, basically, this is kind of what we covered, right, in the past. And if you think you can manage, if you know some Python, you've done some basic stuff, yeah, so just try to follow along, and then see. And you can always go back and right, maybe read. Let's say you're a little weak on visualizing, right? So maybe you cannot do that section, right? So I always encourage people to sort of hang on, and you can always kind of backfill your knowledge, right? So okay, that's fine. So try it for a couple of weeks and let me know how how it goes. Cool, guys. Any other logistics issues? Are you guys able to do all the labs, submit the labs, all that? Essentially, we are using Google Classroom as a way to sort of collect assignments, right? We are not using much of the features, and that's fine, because what happens is when you submit assignments, right, they show up in as Google Google Drives like this, right? And it also makes me easy to share with you guys. So for example, like the last one is 09 data cleansing, right? So I can see your assignment submissions. This is great. And again, one more thing, right? Even if you're late, even if you're doing partial assignment, please do submit it, because at least it'll kind of get you like keep you moving, right? So don't worry. What if you only done like 50% of the assignments? Please go ahead and submit it, and then so this way you can keep moving on, right? So. And then when you get submitted, I always share the submission with you guys, because this way you can learn from other people's code. And last week you guys saw, right, I was highlighting some of the solutions by Kieran and Vasilius. That was great. Right? So that's the kind of level. And each week I'm going to ask each one of you. I'll email you guys privately, right, to say, hey, can I use your solution next week? So this way we kind of spread out the load a little bit, and also give you a little motivation to kind of complete the assignment, right? So you can come back and say, yes, I'm happy to do it, or you can say, oh, this week is busy, please, maybe some other time. That's fine. So, all right. So we are going to continue with feature engineering, guys. Any questions before we do? Okay. So I was going to go into some of the slides, and we talked about, remember we had a very good discussion. Remember, this is called feature extraction, meaning, because machine learning heavily depends on feature engineering, and you will realize this more than algorithms. I would say feature engineering is will give you really good results. So we talked about for example if you want to make a loan, what are some of the features you could use? And we had a pretty good discussion of why each features might be important, and also we had to be mindful that some of the features you cannot use legally, right? So things like age, race, right? These things probably couldn't use. All right, so we had a good discussion. So this is called feature selection or feature extraction. Okay, and in this week's assignment, you guys will see I'm asking you guys questions about these, right? So now we talked about variable encoding, right? So because machine learning algorithms want numbers, but sometimes we don't get all numbers, right? For example, remember in our previous data, I had a data, metal status. Basically, it's like a a string data, categorical data, right? So how do we convert these guys to numbers? So we touched on this. Couple of popular ones you can simply, it's called index encoding or factorization. Basically, you can just assign just a number, right? I say I'm calling married 0, single 1, divorced 2, and then your this data becomes this data, right? And this is fine most of the times, but some algorithms will get confused because they look at the number and they will think this is like a real number, kind of like zip code, right? If I show you a bunch of zip codes, even though they're numbers, they're not numbers. You see what I'm saying, right? You cannot just compare one zip code with the other, as in like, it's one greater than the other. But some algorithms will fall into the trap. They will treat these numbers like numbers. Like, so they may consider and say, oh, okay, I see 2, so that must be better than 1, must be better than 0, right? And that's not the intention, right? I mean, if you look at this, right, it can infer in different meanings. Because all we did was we just randomly assign unique numbers. So if you don't want to do this, right? If you want to make sure the algorithms don't fall into this trap, what we do something called one-hot encoding. Very simple, right? What we do is we create dummy columns, right? As many dummy columns as we need. For example, if I had 10 unique values here, I would create 10 unique columns. It'll basically is married, is single, is divorced, right? And you can kind of see how the mapping goes. Like for example, this row, married, so only this column is 1, everything is 0. Right? So as you can imagine, so what I'm converting is I'm converting a category variable to basically a vector, but a sparse vector. So we can think about what a sparse vector is. Right? Imagine I had 100 columns here. Out of the 100 columns, only one of them is going to have any value, right? I mean, that's what one-hot encoding, right? One, right? Only one can be hot, and the rest are zeros. So one of the questions I had in the last class was, isn't this very inefficient? Like, you're creating extra columns and that's going to take up memory and all that. True, if you did it like the regular way, like imagine I'm just creating 100 columns, right, as regular columns, but that's not how we store this in memory. What we do is, because, even though I get 100 columns, only one has value, right? So I had to just remember that guy. The rest I know they are zeros, right? So the machine learning algorithms will store these vectors very effectively. Right? So don't worry, even if you're converting a large dimension data into one-hot encoding, it's not going to blow up in memory. Okay, so that's one option. Does that make sense, guys? Any questions on this one-hot encoding? And we will, you guys will do the labs on these this week, right? So, all right. And this is the last one we covered. Basically, we said this is called creating new dimensions. Sometimes the data you have, you cannot use for machine learning because the data is skewed or it's not telling the whole story. So you may need to combine the data to create maybe new columns or new features. So example I used was like house prices. And I said if it's a city, this is a median house price. Which city is most expensive? If you just look at the price, you might say this Mountain View, right? That's the highest number. But what is not obvious from here is like, okay, this is the price of the house, but how big are the houses? The size of the house? It doesn't tell me that, right? So if you add that attribute, right, size of the average house, and then calculate like a price for square footage, that's a much better indicator to feed your machine learning, right? So rather than feeding the house price column to your machine learning algorithm, you probably maybe want to feed this price, the green column, price per square footage. Now remember, this green column was not part of the original data, right? It was actually something we created. So sometimes you actually create dimensions to feed to machine learning. All right. So that's called creating new dimensions. And this is basically converting word into vectors. This is a very naive approach, but it just gives you an idea, right? For example, imagine I have a bunch of documents and I want to convert, represent documents as vectors. So this is called document term matrix. So as you can see, right, documents are in the rows, and each unique word we create a new column, and these are organized by alphabet, right? So, And what we do is we simply count how many words per document we have. So document 1 has, 1 cat, one cow, and 1 dog, right? So the vector becomes 1, 1, 1. If we look at document 4, right, we count there are no cats, right, 0, 2 cows mentioned, you can see here, and then 1 dog. So so the vectors basically just combine this vector 0, 2, 1. Right. So what you can see is like you're kind of changing the documents into like numbers, vectors. Right. Again, this is a very naive approach. I mean, these days we have much more complex algorithms, but they kind of work on the same principle, but more complex calculations, right? So this is how we convert. If you have text data, how do you convert them to vectors? Okay. All right, guys. So one thing I want to cover today is scaling and normalization. And then these are you'll get to do the labs on this one this week. So imagine this data, right? Let me look at this data. Let's say this is like, some data we have. Age is one column, income is another column, right? So we look at the range for the age is like, what is like 33 to what, 60, yeah, something like that, yeah. And the income is, what is it, 40,000 or 32,000 to 120,000, right? And even though these are numbers, they are very different ranges, right? So typically this is fine, but what we usually like to do is before we do machine learning, we need to sort of put them into, scale them into a certain range. Why is that? Because some algorithms will need data in scale format. And again, if you don't need to guess which algorithms, the algorithm will say the data need to be scaled, right? And that's our cue to say, okay, if you have data in different ranges, we're going to scale the data, right? So, and there are different scaling approaches. One is called Z scaling, right? So kind of again, you usually do some reading on these. Basically, what we are doing is kind of we take the data, we subtract the average, and then divide it by standard deviation, right? Again, these are fairly standard algorithms, and this is called Z scoring. And there's another one called min-max scaling. I'll show you guys some examples. It will make a little bit more sense, right? So imagine we are doing Z scoring, right? So here's my algorithm, how to do Z scoring. So again, you can see data, subtracting the mean, divide by standard deviation, right? Again, if you look at this, these are all like, one-liner function because I'm using the pandas data frame has mean, standard deviation functions already. Okay. And also, here's how I'm doing min-max scaling. So if you look at the data, let's look at this. This is my original data, right? 1 second, right? The original data. And here in the middle, the Z-score data. Now, if you look at the data, it kind of looks funny, right? I mean, you see like age becomes minus 1, 0.9. How can the age be minus, minus? So you should not take this literally because it's a mapping of, this data into this data. So if you look at something like this, it'll kind of look like this, like the universal distribution, right? Centered around 0, and they can try to adjust, fit everybody into like a bell curve, right? More or less, right? So some data is going to be minus, some data is going to be plus, so that's fine. So you should not take this literally, right? So you should not say, oh, how can the age be negative? That's not the point, because remember, we are shifting the age to a different scale. So Z scoring, right? Z scoring does, usually around zero mean, right? Center around 0. So that's one representation. However, if you compare the one column, right? We compare one column, the relative signals are still kept, right? So, and that's the whole point. We shouldn't be altering the data though, right? We can squish them into like into like a smaller format. That's fine. We can shift them in a scale, right? So what you have to remember is like, imagine you have some data, right? Kind of like this. Let me draw this with a different color. So imagine your data was kind of like this, in a different scale, right? Maybe let's say in a median around like, let's say it's about like 50, around 50, right? So what you're doing is you're doing two things. You're squishing down to between, let's say, even like you say -1 and +1, right? That's a range, right? And then also you're moving it to a zero-centric. So you're kind of squishing the data and also kind of moving the data to the center, but still the same data, right? That's what you have to remember. If you look at the shapes has to be pretty much the same on a different scale, but same shape, right? So that's what you should see, right? This is Z scoring here, right? This is the original data. This is Z scoring. This is min max, right? So z-scoring is pretty popular. Or you can also do something called min-max. So here I'm squishing the data between 0 and 1. If you look at this, this data, right, this column, everything is between scale to 0 to 1. So you can see the minimum age is 33, so that becomes 0, right? The maximum age is 60, that becomes 1. Look at even the income, the same thing, right? 0 to 1. So again, look at the same thing, kind of you're doing this, but instead of doing the z-scoring, do the zero-centered approach, you're basically squishing everything between 0 and 1. Right, kind of like this, right? So 0 and 1, kind of like that, basically, right? So that's it. So again, don't get caught up in the actual numbers. The whole point is you're squishing them and shifting them on scale, right? Within any range we want. I mean, I could have done like 0 to 100 if you like, right? Whatever range we want, right? So again, you guys will do this in the labs, right? So I'm not going to go too much into the code, but the code, as you can see, is just just one liner, right? It's not very complicated. And here's another one, right? Here's the actual code, right? To scale this, right? You can sort of see here, right? Age and income. You can sort of see here, right? This is Z code, right? So I'm creating a new column called age underscore Z, income underscore Z, right? Because now I'm just doing a Z score on all the columns. Okay. So here's a here's a scikit approach. So you can just see here, right? So now we're kind of starting to look into scikit. Scikit is the Python machine learning libraries. Scikit has all these scalars built in. So I'm using something called min-max scalar. By the way, here I'm using pandas, right? So I'm using pandas to basically calculate these, calculate the new columns called age underscore Z and income underscore Z. You can do that too. That's perfectly okay. Or you can also use scikit, right? So scikit has, I'm showing the min-max scalar now, right? So the way it does this, let me see if we can give an example. Actually, you guys will do this in the class. So basically, you have to create a scalar, right? And then basically, we have to fit on the data and then transform. That's it. So fit and transform are basically the key scikit commands here, right? So whatever data you're going to scale, you're going to first fit on the data and we transform. You can also do this in one shot, right? It's called fit underscore transform, right? So here's my original data, right? And here's the normalized data, right? So again, same thing, right? So again, actually showing us examples of how they will look like. So they will look at different range, but the signal shape will be the same, right? It has to be, because we cannot change the input data, right? We can change the dimensions, we can change the scale, but we can actually change the representation of the input data, right? So it'll be the same shape, but on a much smaller scale, and also maybe shifted along the axis. Now, why do we do all this? Because some algorithms will give you better results if your data is scaled and normalized. That's it. Okay. So they're going to make sense, guys. Again, you guys will do this in the labs, right? So again, look at this transform, right? Fit transform. And sometimes people ask me why there's a fit option. So I'll give you an example like this. Imagine there are, I have, say, 5 people of say different heights. Right. Maybe somebody shorter here. Right. And let's say their heights are in, say, feet and inches, right? And if we ask you guys to convert this height into centimeters, right? So you can simply do a little formula to calculate from feet to inches to centimeters. That you can do individually, right? You can transfer everybody's heights independently. You don't need to you don't need to sort of consult anybody else's weight, right? And you get the weights on centimeters. So this is called transform. So when I do transform, I'm changing the data from one format to another format. I don't need to consult with anybody else. Transforms are usually you can do independently. But if I ask you to sort everybody by the height, now you need to look at the entire data, right? And then maybe sort of sort people by by their heights. And that you need to consult all the data, and this is called fit. That's the difference, right? So the transform you can do very easily without consulting everybody. fit is basically you have to look at the entire data to get a sense of the right idea. For example, if we ask you, who's the tallest person? Again, you look at all the data. So that's a fit. All right. But if we just simply say, convert each person's height from, feet to centimeters, that's easy, right? You don't have to worry about others. You can just individually convert everybody's height into centimeter. Is that going to make sense? Okay, so that's the difference between fit and transform. So fit, we'll look at the entire data, right? Transform will basically, you're doing the actual transformation, right? So the reason sometimes you have to fit and then transform is like this, right? For example, let's say I'm asking him to say, okay, normalize everybody's heights in the scale of 0 to 10. Right? Let's say I have some new scale, right? Whatever scale, it doesn't matter, right? I say everybody's height should be scaled into this format. Now to do this, you need to first kind of go and figure that, so 0 is going to be minimum height and 10 is going to be the maximum height, right? So to figure out who's going to be 10, you need to basically look at the entire data set and see, okay, who's the tallest? So maybe this person will map to 10. Who's the shortest? This person will map to 0. And everybody else, kind of map in between. So you need to do a fit first, right? Especially when you're doing things like scaling. So hope that made sense, right? Once you understand this, scikit will make a lot more sense, right? You see this data, fit and transform. These are two main scikit APIs. You'll see them all the time, right? Even when you're training the algorithm, you'll see those. Okay. All right, does that make sense, guys? Let me take a minute here. See if you have any questions. So what you've done is basically we're looking at feature engineering, right? So the way sort of the big picture goes like this, right? Okay. So first feature engineering, right? Yeah, we did like feature selections. Next one, encoding variables, right? When you have string variables, how do we encode them into numbers? Well, one-hot encoding, all that. Now we are looking at scaling data. And these all kind of all fall under feature engineering. Is it going to make sense, guys? Big picture, all right? So those are the labs I set up this week for you guys. You can look at the you can look at the look at the labs. We'll kind of walk you through this. For example, let me look at variable encoding, for example, right? So same format. I'm asking you, here's the data, okay? And I'm asking you to do two kind of encoding. One, I say just do index encoding is like factorizing, just assign numbers, right? And another one I'm doing one-hot encoding. Now you guys have seen this already, right? But now that what you're doing is you're actually writing code to accomplish this, right? That's the difference. I mean, you guys already know. Excuse me, turn this off. Right? You guys have already seen sort of the implication, how we do all that, right? You guys have seen how the data should look like, right? You guys know all this. Now what you're doing here is you're actually writing code to accomplish this. Okay. Right. So that's one. And then next one, so once you're doing the basic one, I'm asking you to do the Prosper data. So Prosper is pretty interesting data. We'll use this later, but let me show you guys the simplified version. All right. So here I'm showing you guys Prosper data. Right. Larger. All right, you guys can sort of see. All right. So this is the data we are going to be using in our machine learning later. All right. All right. So here's a here's a simple data. They made some loans, right? And whether the loans were paid off or not. So immediately when you look at the data, you say, oh yeah, credit score, that's numbers, right? And also, you can see, right, some of them are missing, right? See, right away you can sort of start seeing, oh yes, we need to do some, for example, okay, actually let me ask you guys this, missing data. What do we do here? How do we handle this? I know we had a break last week, but anybody remember? How do we deal with this missing data? What would you guys do? How do we handle this? Anyone? Yeah, go ahead and type in the chat window, or you can just speak up also, please. Yeah. How will you guys deal with this missing data?
You put them in.
Right. So remember, this is a credit score, right? So kind of, we're going to show you the data, right? So this is credit score. So there are a couple of things you can do. You can say, you know what? I'm going to just drop all the rows that doesn't have there's null values, and that's fine too, right? But if you did this, you'll end up using a lot of rows. See, there's a null value. You're going to drop this row. You're going to drop this row, right? And that's fine. I mean, if that's what you guys want to do, that's an option. Or you can say, you know what, I'm going to substitute some value. So credit score here, what would be a value, right? For example, I don't know what this column is. So what should we do? Should we do like 0? I don't know. That seems like an extreme, right? And that's an invalid data. Maybe I can do like an average credit score, which is, let's say, I don't know, 500 or something, right? So this way you can say, yeah, missing values. I'm going to just say average, and then can I continue on, right? Again, these are the things we studied, all these weeks, right? Kind of, how to shape the data. And here's another one, right? Here's another one. Actually, let me ask you, because this is interesting, right? So this is employment status, and as you can see, right, this is empty. How do we deal with this? What do you guys think? Missing employment status, what can we do? Yeah, maybe you can say, you know what, maybe like other, right? It's like, I don't know what is, or something. Maybe you can say, you can come with another one, so unknown or something, you know what I mean? Unknown, if you like, right? That's yep, those are options. Any other option? Any other, any other way of filling in this data? These are some of the, some of the things you use, kind of, in your reading, right? So what you could do, right? But again, there's no right or wrong answer. This is based on your data you're dealing with. You can say something like, when people, usually don't put employment, maybe we can say unemployed, right? Because, people don't want, you know what I mean? Because that could be a valid value here. Right? So, right, again, so it's up to you guys, right? And now, so, I actually shown you guys, you guys have studied about, all the, different ways of doing, filling in missing values, right? Or dealing with missing values. And you will choose one that's appropriate for your data. And even certain column, like, I mean, this column you might put in like an average value. This column, maybe, you need to put in like a, a different value of something else, right? So again, these are some of the things that we need to be aware of. All right, so, so the customers here. Yeah, so that's we always joke, consultants, right? Consultants are unemployed, right, or self-employed, right, with no customers, exactly, yeah. So we'll look at the data. You immediately see, okay, hey, you see this is numeric data, right? So that's fine. This is also numbers, that's fine. But you do see other data that's categorical, right? So first of all, this is a great one. Like, this is like, what kind of loan is it? Text data. We're going to convert this to, right? Either one, you can do one Hood encoding or just assign a number. Either way, same thing, right? Text data, we want to convert. Here's Boolean data, right? We need to convert this to 0 or 1. Right? So right away, you look at the data, you say, aha, these need to be converted. Yeah. So that's why we kind of, we're kind of going through this one. So these are all feature engineering. So one of the, and this is the last question I'm asking. Look at the data, and then kind of, see how do you would encode the data. Right? And so you can decide how you want to encode this. You can decide to do like, simple factorizing. Factorizing means just assigning like a number 0, 1, 2, 3 kind of a number, or you can choose the one Hood encoding, right? So either way is fine. Yeah. All right, guys. All right. So that's encoding. So I kind of broken this into like 3 sections: encoding, and also the next one is scaling. All right. So again, basic reading. So also basically do the checklist. So this is kind of what I expect you to guys know at the end of reading through this, right? So you should be able to answer these questions. If you're reading this and say, I don't really get Z scoring, go back and read again. Right? So that's how we want to make sure you sort of extracted enough knowledge out of these articles, right? So all right, and then Excel, you guys know. So I say, here's a data frame. Okay, go ahead and scale. So I'm saying, okay, do like a standard scaling, right? Do min-max scaling. Right? I'm saying, okay, scale this to between 0 to 100. Again, you sort of go, find code. You can use pandas or scikit. Either one is fine to say, well, how do we do this? Yeah. So, all right. And then next one, I'm saying, okay, now, you're done with, I mean, this is kind of a toy data, right? Just to kind of, right, just get you guys going. And I say, okay, last one, look at the NBA player stats, scale that, right? So if you look at the NBA player stat, you will see, right, there's a, lot of data. So let's focus on the numbers data, right? Again, these, this number is, I mean, this is the, the jersey number, it's not a real number, we can, right? So age is a real number. So we have age here, right? Height. Again, remember the height thing, remember it was, my Excel is doing this is actually in the feet dash inches format, right? So you want to convert it to a centimeter format, which you guys have already done, right? So this is the numbers data, salary data, right? Oh, this is good, salary. Let me go through this one. If you compare age and salary, you will see they're like in a hugely different scale. And especially NBA, right? This is very pronounced because, your age is, like you're pretty, people in the 20s and 30s mostly, right? And the salaries that could be like, hundreds of thousands, millions, even tens of millions, even hundreds of millions. So, and here's a classic example of, why you want to scale data. Because if you look at these two guys, they are in completely different, like, scales. Right? So anyway, so these are things, you should just, can play around with. Now you just have the basic understanding why we are doing this. And also as you just go through and look at the code, you will develop the code to do this, right? That's it, right? So all of this we are doing, guys, before even do machine learning, right? So we look at the sort of the, like a little machine learning, right? It'll kind of go like this. So we are doing this. One moment. Right. So if you look at like a little flow chart, first part is basically, data cleansing, right? So this you have done already, right? So here, you sort of deal with things like, missing data, right? All that. And then next step is basically doing some EDA. What is EDA? Exploratory data analytics. So you're looking at the data and kind of getting understanding of what the data looks like, right? Any missing values. So I mean, usually data cleansing and EDA kind of go hand in hand together because, right, you need to kind of look at the data first to figure out what's missing, right? So anyway, so kind of, imagine like a little loop going on between these two guys, right? So again, if you look at this, that's exactly where these guys are, right? So for exploring data, you might do some visualizing, you might do some graphs, you can do some basic stats to understand if there are any outliers. And once you detect some data is missing, or right or wrong, then you do data cleansing. Okay? So that part is what you guys have done. I can look this here. Okay. Next part is going to be, right, is basically feature engineering. So now you have reasonably clean data. You're looking at, okay, so what's next, right? What are we going to do as next step? Which features do we really want? And this is where you're going to start saying, okay, do we need to encode variables? Do we need to scale variables, right? And then the next step is actually machine learning, right? So actual algorithms. Okay. And the next step, I'll just so we are doing this, I'll just do this, is basically evaluations. Okay. So you guys should be hopefully sort of seeing kind of the the picture, right? Kind of what we are doing, right? So data cleansing, missing data, data analytics, right? Feature engineering. We are right here, right? Next steps, really look at algorithms, and each data you go through, you will kind of go through the same steps. Right? I'll actually put this in the diagram here because I think it's a good thing to have. So it kind of makes sense, guys. Sort of the workflow, and this is pretty much the same for each machine learning algorithm, right? And the reason kind of we spend some time in the early stages, guys, like I've seen people jump right into the algorithms, and you will see this, right? actual algorithm code is, and when they work on notebooks, the actual algorithm code is maybe like 2 or 3 lines, but they will write another 50 lines of code just to kind of go through all this. And for them, like all of them is like a mystery. I think, well, why are we doing all this? Right? Because the algorithm is only 2 lines of code. Because in most machine learnings, right, most of the code is going to be shaping the data. Right? So that's why it's kind of, we need to have some basic understanding of the stages. It'll really save you a lot of time down the, further down, downstream. Yeah. Yeah. So does that kind of make sense, guys? Kind of a, like big picture. I hope things kind of start to, kind of hopefully clear up a little bit, because a lot of the time people ask me, why do we need to learn pandas? Shouldn't we just, look at algorithms? Thing is, yeah, and you will see, we'll look at algorithms next week and onward. Algorithms are very easy. It's just, managing the data is the hardest part, right? Anyhow, so hopefully, I hope you guys can see this. And then, this is what we are working towards. All right, guys, let's see question times. So data in a bell curve, right? So this is kind of, these algorithms are, they're based on a lot of math stats formulas. And, when your data is in a bell curve, of course, everything will work fine. But even if they're not, they will still work. It's just like, they will not give you the optimal answer, right? Because in real world data, hardly, anything is like a, in a perfect, perfect distribution, right? So that's fine. So, but when the algorithms say, they will say, the algorithms will give you optimal answer if the data is in a nice bell curve or something. But, even if they're not, algorithms still work. They're going to be less optimal. And that's fine, because right, most of the data we have in real world is not a perfectly shaped data, right? So yeah, so don't worry too much about this, but when you do EDA, you will know the data, right? For example, like, having a data, not a perfect bell curve is one thing. But if you have extreme outliers, that's another thing, right? If you have extreme outliers, you probably have to go and fix those, right? And that's what these early stages are going to tell you. And a lot of the times when you don't do this early stage properly, your machine learning algorithms will, will give you bad results, or give you, pretty, at least not going to give you good results. The reason, because the reason is the data they were fed into is not, it's not great. Yeah. Good question. Yeah. All right, guys. Any other questions on this one? Right. So assignments are posted. Right. You can check your right. Week 6. Right. So what is it? What is this week? September 14th. Right. I sort of start from Mondays. Right. Right. All right. So assignments. I think these are pretty straightforward assignments. Just do some reading. Right. I kept the assignments live because I don't want to overload you guys too much. And same thing, right? You submit through Google Classroom, and then I'll share the files with you guys. Okay. Question was, can I resubmit an assignment? I believe you can, right? So when you go to Google Classroom, like if you did a submission, and you say, oh, I made a new, I have a newer version I want to submit, you can sort of recall your previous submission and then submit again, something like, right? I remember seeing that. So you can do this, or you can just submit it. You can just give it a different name, right? So either one is fine. Yeah, but yeah, you can definitely resubmit, and you can even resubmit after the date. Even though I said the date is next Friday, right? Even if you're running late, submit anyway. Right? That's fine. Good, guys. What else? So that's the theory I want to cover for this week. You guys have the slide already. Exercises are coming to you guys, right? By a usual means. Anything else we should talk about? Any questions? One of the question is, do we do the same thing for deep learning as well? Very true. Yeah. So, so right now, we are focusing on machine learning, right? So these are the kind of the right. Deep learning, we do the same thing, right? We want to shape the data, especially in deep learning. Scaling data is very important because a lot of the deep learning algorithms expect data to be in a scale format. Because if we just submit the data like like this, right? It probably won't work. So you have to scale down data, right? And this is even more important in deep learning scaling data and all this stuff is important. Yeah, good question. All right, guys, I think that's probably the sort of the theory part of it. So I want to, I want to see if we have any Q&A. Otherwise, we'll wrap it up. It'll be a short session. So fit and normalize, right? So fit and normalize, you have to think, you don't always have to do fit and normalize. Fit is basically kind of the way I remember this is like this. Remember the example I had here? Is this? All right, I think, sorry, I think it's disappeared. So fit is basically if you need to look at the entire data, right? Transform, you don't have to, you can do one by one. You don't have to look at the entire data. Like for example, as an example I used was, right? So you might have a bunch of people at different heights, right? And if I ask people to say, if I say, hey, convert everybody's height, this is the people, ABCD, convert everybody's height into centimeters, that's a transform, right? Because why? I can ask individual people, okay, what's your height? Transfer into centimeters. I don't have to look at everybody else's data. But if you ask you to sort the people according to the height, then you have to look at everybody, right? That's a fit. That's how you're thinking about this, right? Fit meaning you're looking at the entire data to determine, the range and things like this. Transform is simply, right? So you don't always need fit, right? But sometimes you need to do fit first, then only do a transform. Right? So that's why I like to remember it. So for example, excuse me, right? In this data, right? It's a spreadsheet, right? Like for example, you guys did this already, right? If I ask you guys to transform the height from feet and centimeters or feet and inches to centimeters, that's a simple transform, right? You can simply come up with the formula. You guys did this already, right? But if you ask you to arrange everybody by their weight, then you have to look at entire weight to figure out, okay, what's the lowest weight, what's the highest weight, and all that. That's a fit. Yeah. Good, guys. Anything else? Any other questions? Very good, guys. So from our guide, after today, this week is feature engineering. Next week, I think I will jump into, we can do some basic EDA or, do some, I'll probably like to jump into the algorithms. Let's see, I need to look at the curriculum back, but yeah, right. I should be able to, and so yeah, so now I kind of want to pick up the pace a little bit. Now you guys are kind of familiar with how we run this class, right? Let me know if the workload is too much or too little, right? I know everybody has works and everything else, so this has to be this is a part-time thing. I understand this. So let me know, right? We'll kind of adjust our pace and the load based on your feedback. And also one more thing I want to ask you guys is, so I'm giving you guys links, right? If you guys found some good links, like you sort of do, looking at doing some searching around and you find like a good video, good link, please let me know, right? Because these are some of the things I kind of found, but that's not to say there are no other good ones out there. There are tons of content. I do want to include those, right? So if you find like a nice content or an article or a video or something, please let me know, right? Even if you read a book and you like one chapter, let me know and I can add this. I prefer to have them as free resources, but I'm also happy to include some of the books because some of the books are really they are really good to read and they're really good, right? So anyway, so please let me know, and I need your help on this one too. So I want to make sure the guide is a good guide. All right, guys, that's it for today. I don't have anything else. Any other questions you guys want me to answer? All right, good. So this week, feature engineering, and I like to wrap this up this week, guys. And then next week we'll move on, right? So you sort of keep an eye on this one. You can see the assignments. I'll also send out an email. And then you guys know the drill by now. Good. All right, if there's nothing else, we can wrap it up early. It's a short session today. Very good, guys. So thank you. We will see you guys next week. Keep an eye out on Slack. I'll announce the assignment. Okay. All right, guys. Thanks.